morning. Do you hear me? And from which group you are?
CIA 21.
Okay. CIA, yes. Okay, so now,
Yes.
as you know, we are starting advising hours in online format, but I think after a week we can do it in offline form also, maybe after first exam or maybe before the first exam also. So if you have any questions or any problems, you can ask me during this advising hours. So have you considered some kind of samples of the winter exam session?
Yes. We learned in the lectures, yes?
Yeah, of course,
This
of
kind of
course. Yeah, of course.
questions, and I do it at home.
Okay, and any questions from these samples?
No,
Or
пока
maybe
что нет.
Okay. Maybe consider some version now. Just a moment. Let me share something. Okay, so maybe we have considered or not. I cannot remember now, but let's just share. Can you see the sample? Guys? Okay, so here you can see one sample. Have you done it or not? Can you remember? For example, let's start with the first one, then second one. So find the limit here. How can you find here limit in this case? Any idea here? Guys, this is now your time. You need to ask some questions where write for me the problems, and we'll try to solve here together. If you have any questions from this kind of samples or from this kind of exercise examples, you can ask also. So here, the first one, find the limit of the sequence. Here, two parameters, we have alpha and beta, and we need to find the correct answer, which one is correct, and what kind of alpha and beta this is satisfied, where we can find here. We need to find it. Okay, which one is correct here? How can we find it? The second one is not so difficult, I think. The problem here is the first one. Yeah. So here you can check all of them. This 4 of them. Put alpha greater than 0 value and beta is equals to -1 here. For example, this will be now -3 times 2 to the power of n. And here also -2 to the power of n minus 1 also, because of here b is -1. And you can check the correctness of this answer. And similarly, you can find here as b equals to 2 and alpha less than 0 also, where similarly beta is 0 and alpha greater than 0, and beta is 5 and alpha is also 0. For example, the last one, D1, if alpha is 0, here we have 0. Here we have 9 square root of n. Here we have when beta is equals to 5, you get here 5 times 2 to the power of n minus 1. And here 3 times 5 to the power of n. So as n tends to infinity, where it tends, which one is greater, square root of n or 2 to the power of n? Which one is greater here? Students? Where it tends, as n tends to infinity, 2 to the power of n. Yes, power is greater. So that's why here, so it depends on this 2 to the power of n, yes? Because of a to the power of n, as n tends to infinity, if a is greater than 1, it tends to infinity. If a between 0 and 1, it tends to 0, because the base here is less than 1, yes? If base is greater than 1, it tends to plus infinity. So that's why here you need to consider, first of all, this 2 to the power of n. But here you can write 2 to the power of n minus 1. It's like 2 to the power of n divided by 2. Yes, this minus 1 we can write divided by 2. And then here you get here instead of beta. So beta times beta over 2 times 2 to the power of n. And here 3 beta times 2 to the power of n. So I will try to write here just a moment. I need to switch on my next device. Just a moment. So since it's right here, 2 to the power of n divided by 2 times beta, yes, here on top, this side. So, and here in the denominator, we have 3 times beta times 2 to the power of n. So, and now, what we have as answer here, but so we need to check now other ones also. This A, B, C also we need to check, because here it's not satisfied, as you can see. it will be 9 to the power of square root of n and a 5 square root of n plus 1. But here we have the 2 to the power of n minus 1 and 2 to the power of beta is 5 here. 5 over 2 times 5 over 2. We are checking just last one now here, but we need to check all of them, A, B, C also. So times 5 over 2 times 2 to the power of n, and here divide by 315 times 2 to the power of n. Yes, so we need to check it also. Okay, let's check it by yourself, A, B, C also. Okay, do you understand me? So here, check all of them, each possible cases. And now, next exercise number 2. What we have here? Find the limit. Find the limit as x tends to 8. What we have if x tends to 8? What kind of form we have? Students, please be active. What kind of form we have here?
0 divided by 0.
Yes, of course, 0 divided by 0. So if it is 0 divided by 0, what can we do here in Lasha?
Find the highest power of x.
Hard. Huh?
Find the highest power of x. And
highest power? Maybe, but so can we use here L'Hopital's rule, for example? Yeah. Asal Khan, yes, correct. We can use here L'Hopital's rules, of course. Or we can do without L'Hopital's rule also. How? Using the formula a cube minus b cube. Sorry for this incorrectness. A cube minus b cube. Yeah. So here you have cubic roots. Cubic root of x minus 2. So we can do it full a cube minus b cube. And what should we do to do full a cube minus b cube? Multiply by the conjugate, yes, but not conjugate here in this case because of here, not a square minus b square here, a cube minus b cube here to the next bracket, yes, where if you open the brackets here, we have a minus b, yeah, multiplied by a square plus ab and minus b square plus b square, yes. So we need to multiply here to this value. I mean here to the next brackets, to denominator and numerator, and then we'll get something as without cubic root here. Do you understand me? In the denominator. And similarly, we can use on top in numerator the same one. So here we need to use here a square minus b square now. So here we have a minus b. Now to get a square minus b square, we need to multiply it to a plus b also. Yes. So here you will multiply the top, this 9, this one with plus 1 to conjugate. Maybe here we don't have answers. If we compute, maybe we can get to 12 by 5 if you we have already computed it, so we can check it. So I just explaining the rules how to get this result using L'Hopital's rules. It's very easy. Yes, just do derivatives of top and denominator, because of here indeterminate form 0 over 0, or you can use by algebraic expressions using short multiplication formula, a squared minus b squared and a cubed minus b cubed. And it is same. This is your now choice. So you can choose the first L'Hopital's rule, you can choose the algebraic expressions. Do you understand me? Is it clear for you? I cannot hear you, guys. Okay, so can we move to the next one? I think now you can do it very easy. It's now. And answer, Asal Khan, did you get 12 over 5 here when you use L'Hopital's rule? Yeah, if it is 12 over 5, yes, it's correct. Okay, now question number 3. Let f and g, the functions defined by the next way. You can see f and g functions. Decide which one of the following functions discontinues at x equals to 1. And what should we do to define discontinuities? In what cases we call discontinuity? So if it is not satisfied this condition, continuity, it was limit as x tends to x0, fx should be equals to, fx should be equals to fx0. Yes? So this is called continuity. If Sx tends to x0, function tends to the value fx0. So if it is not satisfied, it means that it is discontinuity. It has discontinuity. And what kind of discontinuity we have? We have 3 kinds of discontinuity. Discontinuity of the first kind, second kind, and removable discontinuity. So in this case, when we starting each of them, here also you can see we need to check all of them, A, B, C, and D here. So now to find here this discontinuity as x tends to 1, of course. So check each of them now. You can see here we have the values where x equals to 1 for the f of x and for the g of x. They are what kind of functions? Continuous or discontinuous? What kind of functions are they? In this case here, continuous, because of here we have corresponding value for x equals to 1. And for x equals to 1 here, sine 1. So, but when we do here some composition of these functions, where multiplying to another function, this kind of functions, will we get here continuous or discontinuous functions? Okay, let's check the first one. Sine x times f of x. Where is sine x here? We have here. We need to multiply it. Sine x times f of x. So, and what we get here when sine x, when x tends to 1. What we have here? Be active students. One question. So how we get the links? From timetable, or in the office there was announcement? How we get to link the advising hours, students? Okay. Okay, here announcement in the office, yes. So, okay. So, yes. So it means that all students can join to us. Okay. So now let's continue. So what will be sin x times f of x here? Continuous or discontinuous? What we have here? No idea. Discontinuous. Let me continue the recording. So here, x squared divided by x squared of x squared plus 4. So to solve it, just let's try it with substitution. For example, x squared plus 4 divided by t. Or, here, I think we can divide. Okay, let's do firstly, let's with this way, with t, for example. And then, so here, x squared will be what we have here. We can do with square root also. It will be now x squared, here will be t squared minus 4, yes? So, do you understand me? Why we get here this one?
Yes.
So, and then what can we do here? We need to find here x also, yes? Because of here we need to find dx.
I'm sorry. Here, 4 minus x squared.
Okay, 4 minus x squared. So it's not correct. 4 minus x squared. 4 minus x squared. Okay. So now x squared, 4 minus x squared here also. Just a moment. Let me clear. Okay. So how now let's just denote again 4 minus, where is my pencil? 4 minus x squared with t again. And then so here we have now we can use here also trigonometric substitution also. I think it will be better if you use here trigonometric substitution. X denoted by sine x, for example. Because the here answer is with arc sine x, I think. Yes, there was the choices, multiple choices. Do you have?
Just a second.
It will be with arc sine.
Yes, yes.
Because of here, if you denote by x sine t, for example, let's try to use this kind of substitution. It will be better to get answer. So here it will be now, for example, when you put it to the denominator, here we get 4 minus sine squared t, and 1 minus sine squared t we know. Yeah. So, and here also not sine t, 4 sine t, I think it will be better. Or 2 sine t, it will be better. And then here we have 4 sine. So like this, we can do it. Or we can do, for example, from the, it takes some time. And that's why here it will be better if you just check the solutions here. Try to find derivatives of the given answers and get a correct result. If the derivative satisfies this one, your integral, this will be correct because the derivative of the antiderivative gives us function. Do you understand me, Ilasha?
But here definite integral, it's from 0 to
If you define integral.
Yes.
Okay. If defined integral, we need to solve it. Yes.
Square root of 2.
Square root of 2?
Square root of 2. Yes.
Okay. So if here defined integral, we need to solve it. Yes. So here it will be 4 minus 4 sine squared t. It will be 4 cosine squared t. It will be 2 cosine t. In the denominator, dx will be, look, like this here we have. So if we denote it x equals to 2 sine t, so you get here in denominator 4 minus x squared, it will be 4 minus 4 sine squared t. Yes, so we can just factor out 4 and write here 1 minus sine squared t. And one more announcement, it will be closed after some time, after 5 minutes, I think, and you need to rejoin to the session, okay? So here we have in square root, and top we have what we have in top, x squared, it will be 4 sine square t, yeah, dt. And dx we need to also here, right? Dx will be again times 2 multiplied by cosine t, yes, dt. Is it clear?
Yes.
So, and now here to integrate it, so here we have now in denominator what we have. Two cosine t, yeah? Because of here 4, from the square root it will be 2, and 1 minus sine squared t, it gives us cosine squared t, and from cosine squared t we get here cosine t just, and this cosine t, yeah. So, and here we have 4 sine 6, and here we can just cancel them, yes, this one is this one, and we get here just 4 sine square t dt, and we need to find here this integral. Now it's very easy, yeah. Do you understand me? Yes. Now we can solve it. How we can solve it? It will be this 4 and 2 are canceled here, and 2, and here without this one. 2, 1 minus sine squared t, it is reducing the power. It will be 1 minus cosine 2t, yeah, dt. This one we have now. And when we integrate it, it will be now 2t minus what we have. 2 and 2 are canceled. It will be sine t. Yes, sine 2t. That's all. But now we need to do inverse substitution. Instead of t, now what should we do? What should we put here? T now it will be arc sine x over 2. Just put out instead of t, arc sine x over 2 here. Do you understand me? Joshua, is it clear now?
Yes.
So I think now it's not so difficult. Just put here instead of t arc sine x, and your answer will be now what will be now your answer here? What will be the answer? Do you have the versions?
Yes.
So the answer here is, look, the answer here is, I think it's clear what kind of substitution we need to do. So here answer now, 2 arc sine x over 2 and minus sine, it's minus sine, let me write here.
P over 2 minus 1.
Yeah, minus sine, arc 2. Yes, we have 2 also. Yes, 2 arc sine x over 2. So, and now we need to put here 0 and square